So today, me and my partner will be teaching you guys a lesson over matter and thermal energy. We're going to first start off with matter. What is matter? Matter is anything that has mass and takes up space. Everything around us is made of matter, including air, water, and the objects we touch. Matter is made up of very tiny particles called atoms and molecules. These particles are always moving, even when we cannot see them. All matter has volume. The 3 different states of matter. Matter can exist in different states: solid, liquid, and a gas. A solid has a definite shape and volume. The particles that make up a solid are closely packed together. They are still in motion, but they have so little kinetic energy. In a liquid, the particles are constantly moving, although they are not moving as quickly as they should be if the substance were in a gas state. A gas does not have a definite shape or volume and spreads out to fill the space around it, like the air in the room. Substances and mixtures. Substances is a type of matter with a fixed composition. A substance can be an element or a compound. A mixture is matter composed of 2 or more substances that can be separated by physical means. There are 2 different types: heterogeneous and homogeneous mixtures. Both substances and mixtures are made up of particles. They both can exist as solids, liquids, and gas. What are elements and compounds? Elements, they are pure substances made of only one type of atom. They cannot be broken down into simpler substances by chemical means. Elements are the basic building blocks of matter. A compound is a substance in which the atoms of 2 or more elements are chemically combined in a fixed proportion. For example, water is a compound in which 2 atoms of the element hydrogen combine with 1 atom of the element oxygen. Heterogeneous and homogeneous mixtures. Heterogeneous mixture is a mixture where the substances are not evenly mixed and you can see the different parts. You can easily separate the different parts. But a homogeneous mixture is a mixture where the substances are evenly mixed and look the same throughout. You cannot easily see the different parts, like a heterogeneous mixture. Some examples of heterogeneous mixtures are salad, cereal, trail mix, sand and water, and pizza. Some examples of homogeneous mixture is salt water, sugar dissolved in water, air, lemonade, and vinegar. The properties of matter. Physical properties is any characteristic of a material that you can observe without changing the identity of a substance. Physical properties can change while the composition remains fixed. Chemical properties is any characteristic of a material that you can observe and that produces 1 or more new substances. Flammability is a chemical property because burning produces new substances. A chemical change is a change of one substance to another. Weathering. What is physical weathering? A process where rocks are broken down into smaller pieces without changing what the rock is made of. The rock size and shape change, but its chemical composition stays the same. This type of weathering often happens because of natural forces like temperature changes, ice, water, wind, and plant roots. Chemical weathering is a process where rocks are broken down because of chemical reactions that change the minerals inside the rock. This means the rock composition actually changes into different substances. Chemical weathering often happens when rocks react with water, oxygen, or acids in the environment. The conservation of mass. According to the law of conservation of mass, The mass of all substances that present before a chemical, the reactants, equal the mass of all the substances that remain after the change, which are called the products. Total mass of the reactants equals the total mass of the products. Some vocabulary words that you should know. As you can see, substance, element, compounds, heterogeneous, homogeneous mixtures, suspensions, collide, the Tylenol, the effect, and solution. Now we're going to get into the next lesson, which is matter and thermal energy. We're going to first start off with the kinetic theory. The kinetic theory explains how matter behaves by looking at the motion of tiny particles such as atoms and molecules. According to this theory, all matter is made of very small particles that are always moving. The particles are constantly in motion, and their movement is related to the amount of energy they have. The faster particles move, the more kinetic energy they have. What is thermal energy? Thermal energy is the total energy that comes from the movement of particles in matter. All matter is made up of tiny particles, as we all said before, atoms and molecules. And these particles are always moving. This is because they have kinetic energy. Thermal energy depends on how fast the particles move and how many particles there are in a substance. And now we're going to get to changes of state, but I'm going to have my partner, Donald, read the rest of the lesson.
I'm Donald, and I will be reading the rest of the PowerPoint. Melting and freezing. The melting point is the temperature at which a solid becomes. When the substance is heated, the particles inside it start moving faster because they gain thermal energy. As the temperature rises, the particles break out of the fixed positions in the solid. The freezing point is the temperature at which a liquid turns a solid. When a liquid cools down, the particles lose thermal energy and move slowly. As the temperature drops to the freezing point, the particles slow down enough to lock into place and form a solid structure. Evaporation and condensation. Evaporation is the process in which a liquid changes into a gas. This happens when the liquid gains thermal energy and the particles start moving faster, spreading farther apart. As the temperature increases, the particles move so quickly that they escape from the liquid and become a gas. Evaporation comes in two ways: evaporating and boiling. Condensation is the opposite process of evaporation. It happens when a gas loses thermal energy and changes back into liquid. As the gas cools, the particles slow down and move closer together until they form a liquid. Boiling point is the temperature at which a liquid changes into a gas throughout the entire process. When liquid is heated, its particles gain thermal energy and start moving faster. As temperatures keep rising, the particles move so quickly that they can break away from the liquid and turn into a gas. Plasma state and thermal expansion. Plasma is matter that has enough energy to overcome not just attractive forces between its particles, but also attractive forces within atoms. The atoms that make up a plasma collide with such force that electrons are stripped off the atoms. Thermal expansion is an increase in the size of a substance when the temperature is increased. Substances also contract when they're cool. Viscosity. Viscosity is the resistance of a fluid to flowing. For example, when you take syrup out of the refrigerator and pour it, the flow of the syrup is slow. But if it was heated, the flow would be faster. Water flows easily because it's low viscosity. Cold syrup flows slowly because it's high viscosity. The Archimedes principle explains why objects float or sink in the fluid. It states that an object placed in a fluid experiences an upward force of buoyant force that is equal to the weight of the fluid that the object pushes aside. If the buoyant force is strong enough, the object will float. If it is weaker than the weight of the object will sink. Buoyancy. The ability of a fluid to exert an upward force on an object immersed in it. The Pascal principle states when pressure is applied to a fluid in a closed container, the pressure is spread equally throughout the fluid in all directions. This means that a change in pressure at one point in the fluid will be felt everywhere in the fluid, like car brakes. The Bernoulli's principle describes how the speed of a moving fluid affects its pressure. It states that the speed of a fluid increases, the pressure of the fluid decreases. This principle helps explain many real-world situations. That's why when you cover the end of a hose causes the water to flow faster. The Boyle's law explains the relationship between the pressure of a gas and its volume when the temperature stays the same. The law states that when the pressure of a gas increases, the volume decreases. And when the pressure decreases, the volume increases. The Charles law describes how the temperature of a gas affects its volume when the pressure stays constant. The law states that as the temperature of a gas increases, the volume increases, and as the temperature decreases, the volume decreases. Also, the Charles law can be explained using the kinetic theory of matter. As a gas is heated, the particles that make up the gas move faster and faster. This is what you should have learned from this lesson.
Here are some other videos you might watch to help you understand matter and matter thermal energy a little bit better. Thanks for watching. Bye.